Hello, hello, mic testing. Hello, good. Okay, students, in the last session we have discussed the topic integration and we have seen indefinite integration. In this session, we will continue with the topic definite integration. Definite integration. Okay, what is definite integral? A definite integral has a certain value attached to the integration. While we are finding integration of some certain functions, we will normally associate that answer with constant of integration because the integration represents the family of curves. Here, when we write definite integration, it represents the net area of the given integral. So here we will discuss what is definite integration in this chapter. Okay, now what is definite integration? Okay, suppose consider a function is mapped from domain between closed interval a to b to codomain all real numbers is integrable on this interval, the interval in the domain. This entire function f is integrable on the entire domain and integral of f of x dx equal to capital F of x. What does this statement mean? F is integrable on the entire domain means the function is continuous and it has certain, you can say it is, the function should be continuous, then we can say the function is integrable and it has certain, you can say the curve is very smooth. Sometimes even if the curve is short, even if the function is not differentiable, but still it has to be continuous. Okay, now this integration represents the family of curves. Then f of b minus f of a. What is this f of b minus f of a? Here it is not there anything, but this a is the starting point in the domain and b is the closing point in the domain. So this f of b minus f of a is called the definite integral of f of x. Now we will see what does it mean in the upcoming slide. Okay. Now this is denoted by integral of a to b f of x dx, where this a is the lower limit of the function integral and b is the upper limit of the integral. A is the lower limit and b is the upper limit of the definite integral. And remember, this definite integral will always give the answer net area of the given curve. What is definite integral? It always gives the answer net area. Okay, interpretation of definite integral as an area. We will first discuss this. Let's take a curve like this, arbitrary curve, where this point is point A and this point is point B and the function is continuous and smooth here. Now definite integration means between these two regions, we already know what is integration. It is nothing but summation. Elongated S represents summation of values. What we are going to add? All the y values, that is f of x. What is f of x? That is y. When x is the input, y, that is f of x, is the output. So we are going to add all these values of y. That gives the answer. So when we are adding all these values of y, take any strip. Consider any strip that is having very negligible width. Let this width be dx. Now what we are going to do is, this strip is assumed to be rectangular, as this is a very close point. These two lines are very close. So this strip, actually this y difference in this y values will be very negligible. So we will consider this strip as a rectangular strip. Okay, now what we are going to do is move this dx, move this width of this strip along the entire length between A to B. Then what we will get? We will move this dx in this length and find the area of this strip and add this. This top point is the y value, so we are going to add all these y values. And this represents the area because we have with dx and length is y values. So answer is area equal to integral of y dx. So that is how we get this formula. Is that clear, students? So what does this integrable between A to B represent? It represents the net area of the curve. Okay. Now we will see. Integrable represents the area of the region bounded by the curve y is equal to f of x, x-axis and ordinates A and B. We have already seen this. Next is, one minute, yes. Suppose f of x curve is like this, then dx will be a strip. This will be the strip dx. We are going to move the strip between A and B. So we will get the area of this region. And this area is the net. This area will represent the net area of the function. Why do we call that as net area? Suppose this function graph is like this. Suppose we have a function like this, where this point will be A and this point will be B. Now when we integrate, this does not represent the total area. Net area means this area is, here y values are positive, so we are adding all the positive y values, and here y values are negative. That means we are subtracting the y values. So when we do in the definite integration, net area represents this positive net area minus of this area. So total area is not the answer for definite integral. It is the net area. Is that clear, students? Okay. Next is fundamental theorem of integral calculus. We have actually two fundamental theorems. One is, if the function is area, differentiation of area function will give the integrand. That is the first fundamental theorem of integral calculus. What is that? If we are differentiating a function, first fundamental theorem is First fundamental theorem is of integral calculus is, first what we are doing is differentiate the area function, that will give us the integrand, that is f of x dx, where a is the area, that is nothing but integral f of x dx, where a will be integral of f of x dx. Integral f of x dx. Now this is the area function. Okay, next, second fundamental theorem is what we have seen. Integral f of x dx between the limits a to b is f of b minus f of a. That is the second fundamental theorem of integral calculus. So integral f of x dx equal to f of x, capital F of x plus c implies, then we will have integral of between a to b f of x dx equal to, finally we have to apply the limit after evaluating this integral. Always remember, definite integration is one step more than indefinite integration. First we have to evaluate this integral, that will be f of x plus c, capital F of x plus c, and then apply the limit. Okay, when we apply the limit, this constant will remain same between upper and lower limit. So what we need to do is substitute upper limit first, that will be f of b, capital F of b plus c, minus of substitute the lower limit, that is capital F of a plus c. Here c will get cancelled out, So we will have f of b minus f of a. That means irrespective of what constant we are adding in this, we will always have result same. That is f of b minus f of a. Okay, what does this represent actually? When we are adding the same constant, the result does not change. That means what is the actual use of this constant? This constant, based on the value of this constant, the curve f of x will get shifted above or below. It does not change the shape of the curve. That is why when we are adding constant, it does not matter where this f of x is located, but the area will remain same. That is why we are having this formula. Okay, next is, that is f of b, capital F of b minus capital F of a. For example, we have to evaluate integral of x square dx. What is integral x square? We already know integral x square is x cubed by 3. That is x cubed by 3. Then what we need to do? Substitute the limits. That is lower limit is 0, upper limit is 2. What is the formula? Capital F of, after evaluating the integral, we have to substitute upper limit minus lower limit. That means we will have 2 cube minus 0. 2 cube by 3 minus 0. So what is the answer? 1 by 3 is any constant into x cube is 2 cube. First substitute, apply the upper limit, that is 2 cube minus 0. So answer will be 8 by 3. Easy question. Clear now? This is how we should calculate the definite integral. Okay, next question. Integral of between 0 to 1, 1 by 1 plus x square dx. Okay, now how to evaluate this integral? This is again a standard formula. We will solve some basic problems for getting used to how to apply the integral, that is limits in the integral after evaluation. Okay, we can directly write this answer. What is the integral? Let this be I. I is equal to integral dx by 1 plus x square is tan inverse x. Tan inverse x between limits 0 to 1. 0 to 1. That means first we will apply upper limit, that is tan inverse 1. Tan inverse 1 minus apply the lower limit, that is tan inverse 0. Tan inverse 0. Now what is tan inverse 1? Tan inverse 1 is pi by 4. Tan inverse 1 is pi by 4 minus tan inverse 0 is 0. So final answer is pi by 4. Answer is pi by 4. Clear now students? Easy questions. Next is integral a to b f of x dx is equal to integral a to b f of t dt. What does this theorem mean? It means if we change the variable x to some other variable, the integral value will remain unchanged. That is why this is called a dummy variable. This dx, x is called a dummy variable. Similarly, t is also a dummy variable. So whatever is the variable of interest, variable of integration, even if we change that, the answer will remain unchanged. It is easy to prove. First, what is the evaluation of integral a to b f of x? That will be f of capital F of b minus capital F of a. Similarly, what will be integral this one? Again, it will be capital F of b minus capital F of a. Why do we have same function? Because here f of x, f of t. That means we are having the same function. For example, f of x equal to x square. Then f of t will be, this is the same function f. That means we will have t square. Clear now? So again, when we evaluate and apply the integral, answer will remain same. When we apply the limit, answer will remain same. Okay. So integral between a to b f of x dx is capital F of b minus f of a. Similarly, this is also f of b minus f of a. That is why these two integrals are same. That is why this variable is called a dummy variable. Next one is integral between 0 to 4 x square by 1 plus x dx. Again, first, before evaluating, applying the limit, we have to evaluate the integral. And how to do that? We have to manipulate this expression so we can obtain an integrable function. So how to do that? Here we have x square divided by 1 plus x dx. Okay. X square divided by 1 plus x dx. We can use white color now. X square, we have x square in the numerator, in denominator 1 plus x. So what we need to make is try to bring this 1 plus x to the numerator if possible. We already know x square minus 1 can be factorized into x plus 1 into x minus 1. That means what we are going to do is add and subtract 1 on the numerator. So we can write this integral as, I will write it here. We can write this integral as x square minus 1 plus 1 divided by 1 plus x dx. Okay. Next, what we are going to do? Separate the integral. This is integral of. Now we are going to separate the integral. This is x square minus 1. Take it as separate integral. That is x plus 1 into x minus 1. X plus 1 into x minus 1. Then divided by 1 minute. Okay. Divided by 1 plus x dx plus integral of 1 by 1 plus x dx. Then we will get 1 plus x will get cancelled out. Then this is nothing but integral of x minus 1 dx, x minus 1 dx plus integral of 1 by 1 plus x, log of 1 plus x. So we can write this as plus this value is log of 1 plus x. Okay, we will write this first as integral and then we will evaluate in the next step. This is equal to, what is the answer, students? First one is x square by 2, x square by 2. Then next minus of x, next plus log of mod 1 plus x. Now what is the limit? Limit is given between 0 to 4. So apply the limit 0 to 4, 0 to 4, 0 to 4. Okay. Now this is the answer. So we have to apply the limit between 0 to 4. When we apply 0, 0 by 2, 0 minus 0 plus log 1, that is also 0. That means when we apply the lower limit, all terms get 0. When we apply the upper limit, we will get 4 square by 2, 4 square by 2 minus 4 plus log of 1 plus 4 is 5. So we got this answer, that is equal to 4 square is 16 by 2, 8 minus 4 is 4, 4 plus log 5. This is the answer. Clear? Easy questions? Answer is 4 plus log 5. Let's see. What we need to do, try to manipulate the given expression so it gets converted into integral form. Standard integrals. So for that, we are going to add and subtract 1 in the numerator. Then we will get this, when we divide this first, x square minus 1, x plus 1 will get cancelled. Remaining we will have x minus 1 plus 1 by 1 plus x. Now integrate this. That is x square by 2 minus x plus log 1 plus x. Apply the limits. Next question is integral between 0 to pi by 4 secant power 4 dx. Okay. Now how to evaluate, sir? Secant power 4. We don't know direct formula for this. So for that, what we are going to do is try to split this secant square into tan and secant if possible. So what we are going to do is try to write this secant square x as, we will write this as secant square x into secant square x. Now what we are going to do is, this integral will be integral between 0 to pi by 4 Secant power 4 is secant square into secant square. We will write first secant square as 1 plus tan square, 1 plus tan square x, 1 plus tan square x into, we will write the second as it is, secant square x dx. Okay, now what we are going to do, we have 1 plus tan square x into secant square x dx. Now substitute tan x equal to t. When you substitute tan x equal to t, secant square x dx will become dt. That means this integral will become integral of, before substituting, changing this variable, we have to apply the limit also, change the limit also. So when x is equal to 0, x equal to 0, what is the value of t? T is tan x. We are substituting t equal to tan x. Remember always t equal to tan x. That is tan 0, which is 0. Now when x is equal to, what is the next value? Pi by 4. So at pi by 4, what is the value of t? That is tan pi by 4, which is 1. So this limit gets converted into 0 to 1. Always remember to change the limits. Then this integral will become 1 plus t square into dt. Okay, now we can evaluate this. What is the answer? This is equal to 1 dt integration is t plus t cube by 3. T plus 3 cube by t cube by 3. Now we will apply the limits, that is between 0 to 1. Suppose if you are not changing the limits here, then again you need to convert this t, write this t in the terms of x and then apply the limit. Don't substitute the limit as it is, or don't forget to change the limit also, right? Okay, now what is the value? This is equal to, when you apply the lower limit, t is 0, t cube is 0, so lower limit gets 0. Upper limit value will be 1 plus 1 by 3, 1 plus 1 by 3, that is equal to 4 by 3. So what is the answer? 4 by 3. So what we are going to do is split this, manipulate the given question, so this question gets converted into standard integrable forms. So we will get this as secant square x into 1 plus tan square x. Tan x as t, secant square x will be dt, secant square x dx will be dt. So final answer is, here they had again converted this value t in terms of x. So that is tan x and tan cube x by 3. You can do either way, but always try to prefer in the way we done this. Always change the variable, so there is not a mistake while solving. Answer is 4 by 3. Next is integral between 0 to pi, square root of 2 plus 2 cos theta d theta. Okay. Another good question. Now what we are going to do, integral between 0 to pi, square root of 2 plus 2 cos theta. So we will first try to write this expression as, this is equal to integral between 0 to pi, square root of 2 into, we can take this as 1 plus cos theta d theta. And what is 1 plus cos theta? 2 cos square theta by 2. So we will get integral between 0 to pi, square root of 2 into 2 will become 4. 4 cos square theta by 2 d theta. Now what is the answer? This is integral of 0 to pi, modulus of 2 cos theta by 2, square root of some square number is modulus, square root x square is mod x. So we will get 2 cos theta by 2 d theta. Now how to open this modulus? For opening this modulus, we have to see the limits. What is the interval in which we have to find the integration? Between 0 to pi. Okay, when lower value is 0, cos will be 0, angle is 0. When upper limit is pi, this value is pi by 2. So that cos will lie in first quadrant between 0 to pi by 2. And in first quadrant, cos theta is always positive. That means this entire term will be positive. That is why we are going to open this modulus as positive sign. That means we will get integral between 0 to pi 2 cos theta by 2, 2 cos theta by 2 d theta, d theta. Now this is equal to 2 is constant, we can take it outside. Integral of cos theta by 2. What we need to do? Divide this number, whichever is the coefficient, integral of cos x by 2. Integral cos we have to find, and when it is a linear term, we have to divide by the constant, the term that is coefficient of x. Here coefficient of theta as a variable of integration is d theta. So what we are going to do? Divide by 2, 1 by 2. That will be 2 into 1 by 2 into integration of cos is sine of theta by 2. Now what is the limit? Limit is between 0 to pi. 0 to pi. Now this is equal to, here we will have 4 into sine pi by 2, that is 1. Sine pi by 2, that is 1, minus sine 0, 0. So final answer is 4. Clear now students? Easy questions. So this is how we should solve definite integrations. First we have to evaluate the integration and forget about the limit, constant. Instead of constant, we are going to apply the limit. So here we will have this 2 into 2 cos square theta by 2, that is 2 cos theta by 2. When we open modulus, it should be positive sign. The reason I have explained while solving the problem. Next, this is equal to, again 1 by 2 will be divided and cos integration is sine. Then apply the limit. So final answer comes out to be 4. Next question is, integration between 0 to 3 x divided by square root of x square plus 16 dx. Another easy question. Can you answer now? What we are going to do? By observation, differentiation of the term inside the square root is x square differentiation is x terms 2x. So that is in numerator. We can divide and multiply by 2. Then we will get this expression. If we take this as t, this 2x dx will become dt. That means this integration is of the form 1 by 2 of integral dt by root t. We already know the formula. That is equal to 2 root t. So what we are going to do is, take t is equal to x square plus 16. X square plus 16. That means when x is equal to 0, t will be 0 plus 16, 16. And when x is equal to 3, t will be 9 plus 16, that is 25. Now this integral will become integral of, what is that value? 16, and the upper value is 25. This integration will convert it to 1 by 2 times of dt by root t, dt by root t, dt by root t. That is equal to 2 root t. Therefore 1 by 2 into 2 root t. And after integration, we have to apply the limit, that is 16 and 25. This 2 will get cancelled. So we'll have square root of 25, that is 5, minus square root of 16, that is 4. So final answer is 1. Clear? Easy question. Either you can change the limits and then solve, or you can also solve directly. And then finally, don't forget to change the variable t in terms of x and then apply the limit. Okay. Now we'll see the solution. Integral f dash by root f. Formula is 2 root f of x, dt by root t is 2 root t. So here we will have x by this value. That means when you substitute this term as t, we will have this form dt by root t. So this is nothing but 1 by 2 times of 2 root x square plus 16. Limit is between 0 to 3. And here we are writing in terms of x itself. So we are not changing the limit. So final answer is root 25 minus root 16, that is 1. Okay, next. Integral between 0 to 2. Square root of 4 minus x square. Now again, this is very easy question. Direct integration. What is the formula? Square root of a square minus x square dx. Where a is 2 here. X by 2 root of this term plus a square by 2 sin inverse x by a. That is the formula. So just apply the formula and then substitute the limit values. We will see the solution directly. What is the formula? Square root of a square minus x square dx equal to, this is a is 2 here. So formula is x by 2 root of same function plus a square by 2 sin inverse x by a. Just apply the limit, integrate and then apply the limit. Then we will get x by 2 square root of 2 square minus x square plus a square by 2, that is 2 square by 2 sin inverse of x by a is 2. So finally apply the limit and simplify. Limit is between 0 to 2. When you substitute 2 here, this will be 2 square minus 2 square 0. So first term is 0. 2 by 2 sin inverse 1 is pi by 2. Here we will have another 2. So 2 into pi by 2 is pi. 2 sin inverse 1, that is pi. Similarly here minus lower limit becomes, here it is 0 and this term is also sin inverse 0 is 0. So lower limit is 0 completely. When you substitute upper limit, first term is 0, second term is 2 sin inverse 1. Sin inverse 1 is pi by 2, so answer is pi. Easy questions. Okay, next. Integration of between 0 to 1 x into e power minus x square dx. X into e power minus x square dx. Now for evaluating this limit, we can substitute this minus x square as t. Let's take t is equal to minus x square. Then dt will become minus 2x dx. And when x is equal to 0, don't forget to change the limit. When x is equal to 0, t will be minus of x square, that is minus of 0 square, which is 0. When x is equal to 1, upper limit is 1, t is equal to minus of 1 square, that is minus of 1. That means integral will become integral of lower limit is 0, upper limit is minus 1 into, here we will have minus 2x, so x dx will become minus dt by 2 minus 1 by 2 dt, and here inside we will have e power t. And what is the integration of this? So integration is equal to minus 1 by 2 of e power t. Integration is e power t, so we will get e power t, where limit is between 0 to minus 1. This is equal to minus 1 by 2 of, when you apply minus 1, that is e power minus 1, which is 1 by e, minus e power 0 is 1. So final answer is, when you bring minus to the inside the bracket, we will get 1 by 2 of 1 minus 1 by e. I can write this as e minus 1 by 2e. That is the final answer. Easy question. So here it is all about how to integrate this function, and then we are just going to apply the limit. That is the only difference. So this is how we should solve definite integration problems. So final answer is minus 1 by 2 of 1 by e minus 1 or 1 by 2 of 1 minus 1 by e. Next question is integration of between 0 to 1 by 2 x sin inverse x by square root of 1 minus x square. X sin inverse x by square root 1 minus x square. Now when we observe sin inverse x differentiation is 1 by root of 1 minus x square. So what we are going to do is take this term as t. Let's take t is equal to sin inverse x. Let's take t is equal to sin inverse x. Then what is dt? dt becomes sin inverse x differentiation is 1 by square root 1 minus x square dx. That means this entire term will become dt. And what is x? We also have the term x. So from this we get x is equal to sin t. X is equal to sin t. And then what we need to do? Change the limit. When x is equal to 0, lower limit is 0. And when x is equal to half, what is the value of t? T is equal to, okay, when x is equal to 0, sin inverse 0 is 0. When x is equal to half, sin inverse 1 by 2 is pi by 6, 30 degrees. So that is pi by 6. Okay, now what is the integral? That means we will get integral is equal to integration of limit varies between 0 to pi by 6. Limit varies between 0 to pi by 6 into, then what we get? X is sin t, x is sin of t, and sin inverse x is t, sin inverse x is t, and the remaining term becomes dt. So this is the integration of t sin t dt. Now how to integrate, sir? First thing we can see is this is a product of two functions. That means what rule we have to apply? Integration by parts. How to integrate? We will consider first function and second function and try to integrate this. We will take this. What is the rule to be applied? Highlight. Here what is the first function? Algebra comes first and then trigonometry. Therefore we will take this value as u and this entire value as dv. Okay. Now how to apply this? When we take this as u, finally we don't need to change the limit for now, or if you want you can change. I am not going to change. First I am going to find the integral and then replace it again to t and then we will see. Okay, now u is equal to t, which means du is equal to dt. Similarly, dv is equal to sin t dt, which means what is v? V is nothing but integral of dv, that is minus cos t, Okay. Next what we need to do? Integral of u dv is equal to uv minus integral v du. This is the formula, and that is nothing but integral will become I is equal to u into v. What is u? T into v is minus cos t into minus cos t. This is already integrated, so we can apply the limit. Limit values between 0 to pi by 6, 0 to pi by 6, minus integral of v minus cos t into du. Du is dt, so that is dt. Here minus will get cancelled out. This is equal to minus t cos t, limit is between 0 to pi by 6, plus integral cos is sin, so we will get sin t. This is again limit is between 0 to pi by 6. Limit is 0 to pi by 6. That is it. Easy. So what we need to do? Just apply the limit. That is minus of, when apply lower limit it is 0 anyways because t is 0. When you apply upper limit we will get minus pi by 6 into cos pi by 6 is 1 by 12, 1 by 2. sorry, root 3 by 2. Cos 30 is root 3 by 2. So this is minus of t is pi by 6 into cos 30. Cos 30 is root 3 by 2. Then again sin 30 will be 1 by 2 plus 1 by 2. Sin 0 is 0. Here also we'll get t is 0. So lower limit completely becomes 0. So what is the final answer? Final answer is 1 by 2 minus of root 3 pi by 12. So final answer is 1 by 2 minus root 3 pi by 12. Easy questions. Now we will see the solution. 0 to 1 by 2 x sin inverse x by square root of 1 minus x square dx. We will substitute sin inverse x equal to t and then proceed normally. We already know how to integrate. Then this portion will become dt. So that means we will get, again change the limit value, upper and lower limit into the new variable. Then we will get this 0 to 1 by 2 becomes 0 to pi by 6 and t sin t dt. And this is integrated using integration by parts technique, where first function f of x, second function is g of x. What we need to do? First find the f dash of x, similarly g dash of x, integral g of x, and then use the formula. What is the formula? First you will write u into v. V is nothing but integral of g of x. U into v, that is t into integral of g of x minus integral of this differentiation into this integration, that is the integration, differentiation is dt and integration is integral sin t. So then apply the values, simplify, and we will get the answer. So what is the answer? Answer is 1 by 2 minus root 3 pi by 2. Okay. Next is properties of definite integrals. We will continue properties of definite integrals from the next class. Thank you, students. Always remember to keep learning and keep growing. Success is yours line by line. Endigu endendigu namma tapasya.